Hi guys, and welcome to today's lesson. Title and learning objective are on the screen already, so underneath your last bit of work about adding and subtracting fractions with the same denominator, I would like you to write the new title and learning objective. Pause the video so that you've got time to do that and press play when you are ready to restart. So, last lesson we looked at what to do when we were adding fractions with the same denominator. And so, for example, if we had 4/9 plus 8/9, pause the video and remind yourself how to do that. So if you remember, the denominator always stays the same, and we have a total of 4 plus 8, which is 12/9. That is the same as 1 3/9, which is the same as 1 1/3. All that is revision, hopefully. If you're not clear about any of that, you'll need to rewatch last week's video from Thursday, I think, so that you know that you're fully clear about how to add or subtract fractions with the same denominator. Because today we are taking this a step further by looking at how to add and subtract fractions with different denominators. So let's look at an example. Now I'm going to start off by looking at this situation here, where I have two chalky bars, big chalky bars. And, again, the story involves me eating something, but I wasn't quite as greedy as when I ate all those pizzas. You'll probably be glad to hear. So the first chalky bar, this one, number 1. Now I split this into quarters, which means I split it into 4 equal parts. And I thought to myself, I'm going to eat some of this, but I'm not going to eat it all because I want to save a bit for later. And so I ate this much. What fraction of this chocolate bar did I eat? Well, hopefully you're clear that I ate 3/4 of that chocolate bar. And I ended up losing this little piece here, so I went and bought another chocolate bar. This one, I was a bit annoyed about losing the first bit, and I thought, you know what, I'm not going to split this into quarters, I'm just going to eat half of it. Feeling greedy again. Not too greedy, I'm not going to wolf it all down, but I'm going to eat half of it. So I ate that much. Now how much chocolate do you think I ate in total? That's what today's lesson is all about. Because what we're doing here is we are adding these two fractions. We're adding 3/4, we're adding that to a half, because that's the total amount of chocolate that I ate. What a lot of people who aren't very confident with fractions, what they want to do is they want to do this. They want to go 3 plus 1 is 4, 4 plus 2 is 6. Well guys, that is utter nonsense. So if you thought that was what we do, I'm going to get your purple pen and write nonsense like that. And the reason is, this number here is less than 1 whole. But you can see here, if I ate in chocolate bar 1 more than half of it, and for chocolate bar 2 I also ate half of it, in total I'm clearly eating more than 1 whole chocolate bar. So obviously 4/6 being less than 1 whole doesn't make any sense. So if you thought that the way you added fractions was you add the numerators and you add the denominators like that, pick up your purple pen, make clear that is nonsense. What we have to do when we are in a situation where we're adding fractions with different denominators, so in this one I've got this 4 here, and in this one I've got the 2, what we have to do is we have to somehow get the denominators so that they are the same. Now to show you how I'm going to do this, I'm going to take chocolate bar number 2, and I'm going to split it up so that it's got the same number of parts as chocolate bar number 1, which means I'm going to split it into quarters. Now that I've done that, you can see how many quarters of the second chocolate bar I've eaten. I've eaten 1/4 here, and I've eaten 1/4 here, which is obviously a total of 2/4. Now what I'm doing is I'm able to add these two fractions. The first one is a total of 3/4. The second one is a total of 2/4. And in total, I have 5/4. Or, converting that to a mixed number, 1 1/4. So what we're really doing here, what the most important, the strategy for today's lesson for adding and subtracting fractions with different denominators, is we need to find the LCM of the denominators. Can you remember what LCM stands for? Lowest common multiple. And multiples of a number are the times tables. So we're looking at the denominator for the first fraction, we're looking at the denominator for the second fraction, and what we're trying to find is the first number in both of their times tables. So we look at 2, and we can see 2 times table looks like this. We look at 4, and we can see the 4 times table looks like this. And clearly the first number in both of them is 4. And so I change whichever fraction or fractions I need to so that they both have a denominator of 4. They both have the same denominator. And that denominator needs to be the lowest common multiple. And that is how we add fractions with different denominators. Let's look at another example. This time I'm going to add 5/6 plus 1/8. I want you to pause the video and have a go at this on your own first. Press play when you're ready for me to go through how to do it. So what we're going to do again is we notice that the two fractions have different denominators. We've got a 6 and we've got an 8. So in this situation, we have to find the lowest common multiple of both these numbers. What is the lowest common multiple of 6 and 8? Well, if I'm not very confident, I can just write out my 6 times table and my 8 times table until I find a number that is in both their times tables. And you can see there 24 is the first number in both their times tables, so 24 is the lowest common multiple. Now what I do is I write out the 24 as the denominator for both of them. And then I ask myself, what do I times 6 by to make it into 24? I times it by 4. What do I times 5 by to make it into 24? Sorry, do it to the bottom, do it to the top. So I'll say that again because I made a mistake and I want it to be clear. I ask myself, what do I times 6 by to make it into 24? I times it by 4. Do it to the bottom, do it to the top. Because what we're trying to do here is we're trying to make two equivalent fractions. The 5/6 is the same as the 20/24. Just like over here, the 1/2 was the same as 2/4. Then I go over to the second fraction. What do I times 8 by to make 24? Times it by 6. Do it. What am I talking about? I times it by 3. Sorry guys, it's early in the morning. I'm obviously still not quite awake. Times 8 by 3 to make 24. What do I times 1 by? Well, whatever I times to the bottom, I times to the top. Do it to the bottom, do it to the top. And so this bottom fraction here, this one here, what we're saying is that is equivalent to 1/8. You don't need to write these things out at the bottom here. I'm just writing them there to be really clear about what's going on. When you have 20/24 plus 3/24, you now have two fractions with the same denominator. And so what you're going to do is just add the numerators and the denominators stay the same. So we have 23/24. And that is the answer. If you got any part of that wrong, for example, if you didn't find the LCM, if you found instead 6 times 8 is 48, then make a purple pen note explaining exactly what to do. Make sure that you're following the strategy exactly. You have to find the LCM. And then you have to find equivalent fractions, which is the bits in red. Pause the video, make any notes that you need to, and press play when you're ready to keep watching. So next we're going to do 7 over 12 minus 5, actually let's go with 1 over 6. Following the same strategy as we've been doing so far, I want you to pause the video and have a go now on your own. Now at this point, I'm going to teach you a chant, because the process of finding the LCM for both denominators when they're different, we have a chant for that, and it goes adding and subtracting fractions, find the LCM. Adding and subtracting fractions, find the LCM. So I'm going to write that down in purple pen, because I want you to write it down in purple pen as well. Adding and subtracting fractions, find the LCM. I hope you're saying it with me. Adding and subtracting fractions, find the LCM. So the denominators are different, so we're going to find the LCM. What's the LCM of 6 and 12? Well, it's 12, you can see there. I'm going to write 12 as a denominator of both fractions. You can see 12 times 1 makes 12. Do it to the bottom, do it to the top. It's just 7. It's just the same fraction. 6 times what makes 12? 6 times 2 makes 12. Do it to the bottom, do it to the top. So what we've done there is we've got an equivalent fraction to 1/6, so that the denominator is the same as it was for the other fraction over here. Adding and subtracting fractions, find the LCM. It's all about finding the lowest common multiple. Now I can do 7 minus 2 is 5, and 12 stays as it is. And the answer is 5 over 12. Pause the video, make any notes that you need to, and press play when you're ready to do one more example. Okay, let's make this example quite spicy. Let's do 3 over 8 plus 1 and 1/6 minus, let's go with 5 over 12. Whew. Pause the video and have a go at that. All right, so the strategy, because they're different denominators, but we're adding and subtracting them, we're going to find the LCM. But the only thing we've got to do before that this time is we've got to convert this fraction to an improper fraction. Hopefully you remember. 6 times 1 is 6, plus 1 is 7. And so I'm going to write them all out nicely again. Then I'm going to get on with my strategy. Adding and subtracting fractions, find the LCM. So I'm writing out the times tables of all of them. Ooh, 24 looks like it might be good. 24 is the LCM. So that is what I'm going to make all my fractions with the denominator as being. Times by 3, times by 3, do it to the bottom, do it to the top. Times by 4, times by 4, do it to the bottom, do it to the top. Times by 2, times by 2. And now I've got 9 plus 28, which is 37, and then I take away 10, which gives me 27 over 24. As a mixed number, I would say how many 24 is going to 27, but remember guys, always make your life simple, simplify first. So dividing both of these by the highest common factor, which is 3, I get 9 over 8, and then as a mixed number in its simplest form, how many 8s go into 9? 1 with a remainder of 1, and the denominator stays the same. Again, if you made any mistakes or you weren't sure how to do that, make sure you've made very clear purple pen notes on how to get that right. Pause the video and press, and actually this is now the end of the video, and what I want you to do is show my homework very carefully so you know what Hegarty task you need to do to practice this and to show that you've watched the video. Thanks for watching. See you later. Bye.